This talk was organized was, we were having a discussion with Sanjay, and he said this session is enterprise GIS, and NRSC does some activities which are for governance and development. Can you describe what you do? So I thought it is very easy. I will tell what my office does. But let us see what how I should cover it up. I'll explain about NRSC's campus activities, and we are linked to Earth observation missions of ISRO. How do we organize our GIS work in the various process flow? Our geo platform, which is called Bhuvan, and we have 4 major activities: natural resource inventory, mapping, management, disaster management, climate environment studies, and the new initiative you have been hearing about when we had the meeting on 7th September in Delhi with the last session by the Prime Minister, how to enhance the governance through geospatial activities. Hopefully, I should be able to get through in 30 minutes. NRSA was established as an autonomous center by DST in 1974 and established its research flight facility with the Canberra aircraft in Bangalore. Since then, we have transformed a couple of times. Currently, we have 6 campuses. At Hyderabad, we have a ground station, Earth station in Shadnagar, 4 regional centers, and we have off-campus technical facilities. We have a satellite ground station in Antarctica, thanks to help from Dr. Shailesh Nayak. We also have a hangar, and we have field observatories measuring carbon flux towers at a couple of, half a dozen locations in the country. We are in the area of data acquisition, aerial and satellite. We have not written ground-based because now we are full of sensors, and everybody collects now ground geospatial information. We do process data, mostly over India, but some of the global missions of ISRO, we get global data through our cooperative Earth stations. And since our first antenna for Landsat 2 that happened in January 1979, we have been archiving all the data over India also. From there, I would like you to go across the panel on the right lower end. NRSC has been mapping India. So thematic mapping of India has been one of our core strengths. And I'll come back to the number of themes which we have mapped. But you have heard the previous 2 lectures. The amount of data is so large. We live in a dynamic world, and we also live in a world where the need is to access this dynamic information. We have built WebGIS platforms. There is one which we built for an organization called Center Water Commission. So we only have the mirror and update it. They run the major thing. Other, we have a Bhuvan, which is a multi-purpose. We also have a national database for emergency management, which is on a VPN, which has the data which government sometimes classifies as restricted, and which is only given to the disaster relief agencies through a controlled access mechanism. So this is in a nutshell what we do. Roughly 9 Indian remote sensing satellites, about 5 foreign satellites, and 2 aircrafts, ALS. We have a ISRO developed SAR also, plus LFDC type of cameras, which we do special resolution products. Plus we collect a lot of field geospatial data also, starting from a very simple GCP library to other information. This, I have put the sensors which we are acquiring. Some of them, what you see in yellow, are the ones which are the years mentioned will not be there. There will be slightly delay. We only have ResourceSat 2 this year, and SCATSat also we will have, while OceanSat 3 and RESAT 1A will be there. So roughly that keeps us busy, about 2 passes per day and day and night passes, and we do the operations also. So what roughly, first thing what has happened is, we have, everybody has talked of explosion in data. So our data acquisition speeds have moved from about 15 Mbps one mission to almost from 640 Mbps, and that too from so many satellites. Same way, our processing, something we used to process 15 scenes per day to about 1,000 per day over India, what we do. But what is going to happen in next 2 to 3 years is that roughly, we, in 2.5 days, we collect currently a terabyte of data, but each day we may collect about 5 terabytes just 2 years down the line, given the 2 Cartosat 2E and the GISat. Also, what the lower panel, what you would see is, as of now, except the Cartosat 2, which is 2.5 meter, and Cartosat 3, now 70% of the data which is disseminated by NRSC is actually free download of LIS3 and AWIFS. Only 30% of the data is the LIS4, Cartosat, and the other data which is actually, which constitutes a sale. More importantly, this entire processing is linked to a set of systems. In 2013, we established what is called Integrated Multi-Mission Ground Segment for Earth Observation Satellites, INGEOS. In INGEOS, you have multiple antenna. Up to 10 minutes before the pass, you can assign any antenna to any satellite. Actually, that also happens semi-automatically. Then the data goes into a common storage, state-of-the-art 3-tier storage. And from the storage, the user, through user order and processing system, he can see every 3 seconds updated where our satellites are, what pass has been programmed, and within 30 minutes after the pass, he can check whether that data was acquired or not. He can order the data, he can see the status of the data. Now from the INGEOS environment, we have an application environment where most of our application scientists do feature extraction. While that is done inside, all outputs, they move on to a platform called Bhuvan, which is actually a public platform, multi-location. Red lines indicate that is publicly accessible, UOPS, Bhuvan, and for NDEM. Now, so what we have done now is, since Bhuvan has the user data also, we have moved Bhuvan nodes to user premises so that the better interaction takes place for these other applications. So, the Bhuvan platform by NRSC, the collaborating site, public access, all that is actually linked in an entire data acquisition to the user decision support is actually contained, where each person has given responsibility, access, and right. We have really built this system in past couple of years, and we have some data sets to support the processing of that. Most important is a digital surface model. This is based on Cartosat. It's a 2.5 meter stereo. This data, the version 3, which we released for entire SARC recently on 10 years of Cartosat 1 mission, it has an absolute accuracy of 4 meter, the XY accuracy of 15 meter, and then recently a couple of other countries have also been done. This is basically used for ortho image, and based on this, we provide a WebGIS platform, as I said, Bhuvan. We also have services in the 4 areas, and then we do projects. Now, how does it lead to, just another word about Bhuvan. You can, currently the government regulations suggest that on the web we can only put 1 meter data. That's why Bhuvan restricts to putting 1 meter data even when it is from the foreign sources. It also has maps, base and thematic maps for large number of features. In fact, all maps are OGC compliant and WMS and WMTS available. Entire thing is available. It has a lot of free data to download. list 3, AWIFs, 30-meter cartodem like Aster. A range of applications are built over Bhuvan. I'll come to it. We have services, disaster, weather. In fact, Dr. Shailesh will remember that he has been at INCOIS and also has headed the IMD. In fact, there are some areas where we exchange services with both INCOIS and IMD. It's available. And then we have crowdsourcing. I'll come to the size and the applications of crowdsourcing. It's more a volunteer GIS than crowdsourcing. So let us talk of natural resource management. Every year, using 50-meter data of every month, we map the national land use and also the cropped land and each pixel in which season it was cropped, whether Kharif, Rabi, it means monsoon, winter, or in the summer. This we have been doing every year since 2004, and combining 10 years of data, not only we know the exact history, parallelly this data is available state-wise for download. Every 5 years, we map land cover, land degradation, geomorphology, plus we have built the new applications on the forest. I'll come to that in a moment. All this data and the groundwater data is made available for various applications as WMS layers. You can roughly see this. This is the hydrogeology map on groundwater prospects, also available at WMS. To that, it is linked to the surface water quality. So not only you know the type of terrain, geomorphic feature, likely yield and depth of water, you also have most recent, if assessed, the water quality, a pre-monsoon and a post-monsoon. In fact, 3 decades ago, NRSC did the first forest cover map of the country. That led to regular biennial forest mapping and establishment of the Forest Survey of India. We have really relooked at this entire forest application and produced 4 more things. One is within 20 minutes of satellite pass, we actually have 2 satellites and day and night both we work. We track each location of fire, and if it is in forest, automatic SMS goes to the DFO of that area. This is one thing which we have worked along with the Forest Survey of India. Parallelly, based on our experience of the land use land cover, every 50-meter change in the status of a forest to deforestation location, the location and the year in which that forest point was lost, we are calling it forest loss locations. And recently, we completed the first L-band SAR forest biomass map of the country, which combines the ALOS SAR data, NDVI, the modeled extrapolated height from ice set glass tree height modeled with the forest type, along with the climate and the geospatial layer. So that is the one which I have put a 50-meter forest biomass map for the country. Parallelly, we have looked at historically all map at 50,000, so tried to produce from 1930 to 2015, where the deforestation has happened and the pattern of the change. More importantly, using Gagan, and we have tried to resolve the cadastre, the rural and the forest boundary to really create reconciled forest land at 10,000. This is the collaborative work which we are doing with the Karnataka Forest Department. In fact, the challenge is much more. Not only this has to be done between the forest land and the rural cadastre, same thing has to be done in the urban survey areas also, where the precision requirements are much higher than what exactly is happening here. We map every flood in the country with SAR data we map. We have been doing it for past 15 years. We have produced for the first time actual one-time inundated map of the country. In fact, the Rashtriya Baad Ayog in 1970 said 40 lakh hectare is the flood-prone area. But we actually have produced actual map if any time it is flooded, and then you see that. Plus, the maps of flood of every year have been converted into flood frequency and flood hazard zonation at 30-meter pixel. And for 5 states, they have been put on the web for disaster risk reduction and also shared with the state disaster management agencies. That is another application, a very important geospatial application. Parallelly, what we have done is, using the ALS, we have looked at the terrain, and through hydrological modeling, we do a spatial prediction of flood. This is happening in Godavari and Mahanadi, and we are going to add much more layers to this. Using our geological maps and lineament maps, the landslide susceptibility and predicted rainfall for next 3 days, we actually produce a landslide early warning system. This is done for the pilgrimage routes in Uttarakhand at the moment. In the area of climate and environment studies, we work on the atmosphere like ozone, we work on greenhouse gases, plus a large number of products which you can download under a NICES National Information System for Climate and Environment Studies. I'll just show you 2 examples. On one panel, what you see is originally with 50 kilometer, now reprocessed 25 kilometer OSCAT surface wind. We actually can produce a wind, and then from the wind, the other additional derived map. On the other side, what I have put is from the NDVI and the modeled primary production, plus we have a ocean exchange model added to atmospheric transport model, and we actually can create the vertical CO2 concentration every 6 hours for the global level through the GeoScam model. All these can be very useful for climate studies, because the carbon dioxide and ocean, the cause and where through that impacts are going to be modulated. I just wanted to cover this up. That brings us to more closer to what we all wait for good governance. So how geospatial can help in good governance through some of the activities which we are currently doing. Urban housing for all. In this GAIL, the Gas Authority of India, for a pilot section, monthly Earth observation data is registered and provided, so they can see whether their right of usage has been violated or if there is any issue. 3500 cultural monument and the management zone where building permission is required has been done. We have actually, for National Urban and Information System, a 10,000 scale mapping of the city, which we have helping the urban local bodies to use it for master plan. But for Amrut 500, the smart city, NRSC would be facilitating 1:4,000 scale mapping for 500 cities, which will go as an input for master plan as well as the making smarter cities. These are some of the citizen-centric application. Let me, in case of housing, it's the AP State Housing Corporation has built about 4 million houses. With a smartphone application, each house, 2 photographs from front and side, and a 14 parameter, the beneficiary, the size of the house, etc. All that was done by them over a period of 4 months. Some 4.14 million houses, 2 photographs each, 14 parameter. This is linked from the Bhuvan to their MIS. For houses under construction, they release money. Similarly, for post offices, some 159,000 post offices in the country, where they are, what services they offer. So this will link with the postman beat. So roughly, it will help in the smart delivery of parcels to that. Similarly, for election, where the election booth are, what are the basic minimum feature, also linked it to the incident reporting analysis and vehicle tracking. It's in the rural development and planning where you would have seen yesterday also huge emphasis and funds are. Government has schemes, they have a classification of assets. So we have actually built on Bhuvan, a Bhuvan Panchayat, which is specifically meant for rural asset tracking, making development plan and linking them by the activity as permitted under the various flagship programs of the country. This is one of the major focus of that as of now. Similarly, where each for the MNREGA and the rural water supply scheme, any activity has taken, it is geotagged so that there is a transparency and tracking of the actual asset created vis-a-vis its use. You saw similar examples. So Telangana, every water asset, whether it is a hand pump, whether it is a overhead tank, etc. for community is actually mapped and linked to that. Here is the IWMP integrated watershed management program, where the idea is for all the 55,000 watersheds which have been created, map the assets and create. I thought I'll just give you one more example where the nationally one has to do crop forecast, which is done by Mahalanobis National Crop Forecast Center. Parallelly, there are issues with respect to quality of crop cutting data for yield, or whenever there is a hailstorm or crop insurance, in which field crop damage has done. So through mobile app and the geospatial support, we have provided apps where from the field this information is collected and instantly through this website is available for the crop forecast center, either use in the analysis or use in the disaster support or crop insurance. Crop insurance is going to be the next challenge for us to work together and provide timely things. Future challenges are, we are going to have new missions, 3 missions this year, next year another 2, so every year next 2, 3, we have another 5, 6 missions. Volume, now for most of the multispectral things, the feature extraction and geophysical parameter is the issue. More importantly, for each of the mission, given the sensor, the geophysical features don't have the same type of characteristics, how to have a homogenized thing. Plus, as everybody has been talking since morning, this will be sheerly flooded with additional data from ground operated sensor. Finally, they have to be seen together. And how do you really build this type of information system for 2 major applications: decision support system and sustainable development science, climate science, and also the policies for development. This remains the challenge which NRSC, through its activities, processing, and the support and the platform what we have built, we hope to achieve it. Of course, with a large number of our partners and collaborators which exist throughout the India. Thank you very much.